Hi, Assalamualaikum, and good evening to everyone. We are from Group 1. Today, we are going to present a general critique about the algae as a food. My name is Nushaira binti Muhammad Sabri, and my matrix number is 20350. Next page. Okay, the first journal is Saved by Seaweed, Economic Contribution in Time of Crisis. The main issues is food crisis. The first one, seaweed during the times of famine and hardship. The second is the seaweed during the times of war and international conflicts. How did it happen? The fact is that in the extreme conditions such as shortage and war, humans have turned to seaweed in times of the need mass and create new opportunity for their use in order to mitigate the disaster. Lesson to be learned from the history can be used as the reminder and inspiration and as the guide as how to turn the seaweed in current and in inevitable future times of crisis. The methods during the famine, the access to the foreshore with the rich vegetation of nutritionally dense seaweed become the last resort for the starving population. The seaweed have come to rescue during times of warfare. The scarcity of food during the World War II raised people's interest in seaweed food. The research strength, uh, the seaweed rescue and promote to combat the hungry in poor area in southern Chile. The second one is seaweed surprisingly come to rescue during time of warfare, not only by providing food that is high in the nutrition, but also provide a little extra and welcome source of income for the pupil, for the poor people. The unanswered question, until recently, the contributions of the coastal seaweed and the vast population of the microalgae in the ocean, in the open ocean, to the sequestration of global carbon was largely neglected. Although the Smith 1981 already point out that the marine microphyte work as a carbon sink. The reason for not taking seaweed into the calculations of the so-called the blue accounting was predominantly because the seaweed, in contrast to the seagrass dominated ecosystem, they did not deposit the carbon near their own rocky habitats. The future plans, the scientific research, industrial innovation, and new operation can, together with the governments and multilateral organization, open the path for the new industry to deliver on the 17 UN Sustainable Development Goals. Next, the second journal is the role of seaweed in the future food system. The main issue is the future food system. How did it happen? The seaweed are a natural protector, absorbing the force of the sea by depositing the wave energy and preventing coastal erosion. However, the sustainable of the seaweed production depends on the intensity and the size of the farm, as well as the carrying capacity of the system. The alteration of the physical and the biochemical environment can occur when the sector upscales the production level. For example, if the farm is too big or the cultivation is too intense, um, the nutrition uptake can affect the primary production, which is the phytoplankton. By affecting the phytoplankton, the food the primary by affecting the primary production of the food chain, a tipping point could be reached after which the ecosystem is affected beyond acceptable level. The methods is it is often claimed that the seaweed can end the climate change due to its capacity to take up carbon. However, the carbon taken up isn't equal to the sequestered carbon, the long-term storage of carbon. If the seaweed used by the organism, marine or terrestrial included human, the carbon taken up eventually be released again and cannot be calculated as sequestered. The research strength, Seaweed mariculture is perfectly fitting solution to secure food and feed demands, all the while avoid placing additional pressure on the arable, available land and freshwater resource. As the seaweed are seen as a sustainable resource with a low environmental impact, the interest is using seaweed as animal feed has been increasing over the past decade. The unanswered question, knowing about the positive effect of the seaweed, which is capturing carbon, researchers and the private sector have tried come up with a solution like using the excess of the sargassum for future purpose. But there are many challenges that remain to be solved. The future plan related to the related to the vision of having seaweed cultivation in between the wind turbine is in so-called multi-use area is very promising and provide efficient use of the marine space. However, further development in seaweed research and industry is needed since there are still a number of safety and technological issues that remain. I'll pass to the next presenter.
Okay, thank you, Nashahira. So I will continue. My name is Hanafati binti Kamar Arifin. We metric number is 204243. So the first journal title is a microalgae germplasm food crisis, which is that food crisis that happened because of the threats to the climate changes and how did it happen. The food crisis is happened because of the threats to the climate changes, like the, for instance, the global warming that caused the increasing the sea surface temperature is the leading to the drastic alteration in the marine population, communities, and ecosystem, which is one of particular concern in the potential for the loss of microalgae, which defined as a benthic eukaryotic algae, and which function as the primary producer and habitat and for food. Because of these climate changes, the production of other food beside algae also affected. Since the most of the marine animal eat algae, thus when these food chains unbalance, this affect the food production, which they create the food crisis. So how they need to address the problem, which is the method. So therefore, to the overcome the low production of food because of this natural disaster, researchers did a research by preserve the marine alga via the germplasm banking with an overview of the technical advancements for feasibility and ensure success that the germplasm banking is inspired through an at-situ seed banking, which researcher preserve the heirloom strain ecosystem restoration and the diverse research application. The researcher can culture more algae as food for the future resource. So the richest strengths is through the germplasm bank represent the opportunity to provide the long-term preservation of the important strain and the diversity of the strain. This bank also have the important implication for conservation efforts and provide more importantly as a potential for economic approach to conservation and restoration effort. So the unanswered question in this journal that is say the major challenge for the cost production to this project, which involved to document the algae diversity across distribution, is a one of high cost, which is high cost when one to identifying which species to prioritize to preserve what algae. For example, is a preserve from the 7 to 170 species. It's a lot. So, what the future research for the future plan is aside from the germplasm banking, from the alga, the research start to explore through the innovation in the microalgae aquaculture is optimizing from the Asia. They start to explore is it used for the biofuel production. So next, So the next journal is a microalgae as a sustainable aquatic ingredient. So the main issue is about the fish food crisis, at which is the mean that lack of the aquatic ingredient. So how did it happen? The rising the demand, the production of fish meal and the fish oil from the fisheries, and the rising demand for the finfish diets that cause increasing of the feed costs, which make the ingredient for aquafeed become limited and cause food crisis. So the method is the researchers found the algae can become the sustainable resource of feed material as a replacement for fish, fish meal, and fish oil, which seaweed could offer a viable alternative and relief to the demand of the other ingredients used in the aquafeed. So one of the other method is they use the fermentation that has been a key method for preserving plant and animal food material within the aquarium. The seaweed cannot offer more than just a supply of active compound in the microalgae that can benefit farm fin fish. The use of the microbial fermentation on the seaweed can also yield a range of beneficial by the product. So the unanswered question in this journal that the struggle facility to process the large quantities of the material collected, such as those being generated from the algae bloom. So the future plan for these research is the research has a strong interest among the researchers to develop a renewable energy source using the microalgae as the feedstock. So that's all from me, and I will pass to the next presenter. Thank you.
Thank you, Hanan. My name is Nur Farah Adila binti Yusuf, and my metric number is 202388. So, moving on to the next journal critique, which is from my part, the freshwater microalgae as a promising food sources. And the main issues here is the food crisis that is worsened in 2020, resulting from the economic impact of COVID-19 and also the extreme weather, as the previous presentation has been mentioned before. And how did it actually happen is because of the effects of the climate change. For example, the increase in the temperature, the decrease in water availability, and increase in the carbon dioxide, which have influenced the crop productivity to be decreased. And also, the harvest of the crop is actually expected to change by, as you can see here in the slide, to change by decrease 70% for the wheat, the corn, and also other species of crop plants in the Africa and also the South Asia. Okay, so moving on to the method on how they are actually using the microalgae as a food sources is microalgae can be used as an alternative foods because of their nutritional contents. And also in China, for example, people have actually long used microalgae as a food sources. And commonly used microalgae include Atrospira, or another name is spirulina, the nostoc, and also the Aphanizomenon. Okay, microalgae as food stocks began in the Second World War, like the first presenter said before. Okay, so the strength of this research is actually the microalgae have a very high nutrient content, which mainly what we are going to look at is actually the proteins and also the lipid, as well as the vitamins and also the minerals. And some of the freshwater microalga species actually contain proteins that is similar to those of traditional protein sources. For example, we have the beef, the eggs, the chicken, corn, and beans, and actually many more. Okay, so for the unanswered question is, many researchers are only interested in studying their physiology and how they actually respond to the environmental change. So as a result, many freshwater microalgae species are still unknown. Okay, so for the future plan is actually the countries that do not have beaches, and also or the adjacencies, they can switch to the cultivation of freshwater microalgae. And the researchers can also develop various processed foods from freshwater microalgae. What we need is actually more development in the research. Alright, so moving on to the second journal, which is the commercial expansion of ingredients from algae into human food products. Okay, the main issue is the same as the previous one, which is about the food shortage and the finite planetary resources. And how it's actually happen is according to the recent National Nations report, the world's population is expected to reach for almost 10 billion by 2050, which is a very big population, and it is estimated that the quantity of food production must be increased by about 60%, which is also a very big amount in order to support the world population. Okay, so the method here is that the microalgae have the ability to grow in non-potable water that can reduce the need for the fresh water, which is we know that we have problem with the water sources, fresh water sources, and also this microalgae is one of the thing that we not directly use the fresh water, and also they can be cultivated on non-arable lands. Thus, it is not in direct competition with traditional agriculture. Therefore, microalgae present an opportunity as an alternate supply of protein to reduce the pressure of our rapidly expanding population. So, for this one, the strength of the research is macroalgae have notable features compared to common food crops, such as having a high lipid content and high growth rate when compared to oilseeds, such that algae produces biomass that is 7 to 20 times higher than the soy or corn. Okay, so for the unanswered question is that dairy products, something like yogurt or ice cream, is actually very challenging product to be enriched with microalgae because of the the fishy taste of the algae, and the color is not so interesting to the people. Okay, and so the last one is the future plan is that as we know that only whole microalgae cells that are incorporated into foods were examined and not microalgae ingredients like protein or lipid. Accordingly, future investigation are needed to describe the sensory properties and the fractionated microalgae ingredients and also the effect on food quality. Okay, I think that's all from me. We move to the next presenter.
Okay, so I will continue with the journal entitled The Potential and Challenge of Microalgae as Promising Future Food Sources. So as for the main issue is the food crisis that might occur in the future. And this happened because of the first one is the increasing global population that is proved by the FAO, and also the COVID-19 which we encounter for the past 2 years that affect the production, distributions, and also the consumptions of foods, and hundreds of 30 million people will fall into the hunger, according to the United Nations 2021. So for the methods in this journal is that it reviews two things, which is the first one is the spirulina made into yogurts, and it improve the dietary fiber content up until 50%, and also Chlorella minutissima, Isochrysis galbana, and Phycochlorum species in the fish burger can significantly improve the carotenoids and also the chlorophyll content. So as for the research strength, is the first one is to provide the varieties of evidence for the introduction of microalgae in the various types of foods, and reviewings on the exact amounts of the addition of microalgae, which is necessary for the future references. As for the unanswered questions, developing microalgae into artificial meat is the unanswered questions, and for the future plans is to select the suitable microalgae in respects of their toxicity, chemical composition, digestibility, and human bioavailability in order to develop microalgae bias foods. So next. So the next journal is entitled Using a Bee Phycoerythrin Extract as a Natural Colorant Application in Milk-Based Products. So the main issue Is the first one is to produce a suitable food colorants for milk-based food and beverages. And the next one is to investigate the stability of those compounds from the microalgae to be used as a natural food colorants. So this happen is because of the toxicity of the current synthetic foods and beverages dyes, and some parameters need to be taken, such as the stability, the cultivations, and also the extraction method to extract the compound from the microalgae, which is come from the Porphyridium cuantum. And next one is the methods. The first one is it compare the milkshake in the market with the solution of the milk with the BPE extracts and the repetitions by the using of the liquid yogurt to investigate the amount of BPE extract needed to have the best result that match the commercial products in the market. So as for the research strength, it compare the commercial products with the sample, and also the liquid yogurt uh, proved to need less volumes of BP extract compared to the milkshakes. And the unanswered question is the toxicological addition to its antioxidant capacity of BPE, and also the toxicological implications of phycoerythrin's application as a natural colorant. And last one is the future plan is to expand the list of the food dyes that naturally mates from algae, plants, and fruits instead of the synthetic food colorants. So that's all from me. Thank you.
So next, my name is Nufarisha binti Norisham. My metric number is 202190. The title is Effect of Dietary Microalgae on Growth Performance, Nutritional Value, and Meat Quality of Broiler Chicken. The main issue is the microalgae used as feed additive for enhancing the growth performance and improving the meat quality of the broiler chicken. How did it happen? The use of antibiotic usually to improve the production performance. However, there is a risk of having the antibiotic residue in the meat. The method used is the chicken will divide it into four groups. All groups are provided with clean water and safe environment. One group is fed only with basal diet as control, while the others group is fed with basal diet with supplemented same dose of dried powder of Chlorella vulgaris, Spirulina platensis, and Amphora coffreaformis. The group performance and the breast sample then were taken to analyze the overall quality of the meat. The research strength is the inclusion of the microalgae in the feed of the broiler chicken increase the meat quality of the breast muscle and have a positive effect on their growth performance and also antioxidant status in the broiler chicken. Unanswered question. The weight of the control group is not met with the average weight of the broiler chicken according to the performance guide for the specific breed. For the future plan, the future study is to evaluate the effect of combined supplementation of the microalgae on growth and meat quality of the broiler chickens. Next. Okay, the next gen- So the next journal is the incorporation of microalgae to improve nutritional and sensory value of white chocolate. So the main issue here is the white chocolate nutritional value can be enriched by incorporating microalgae in the chocolate. How did it happen? So there is increased demand for healthy and nutritional foods that accelerates the development of food enrichment with bioactive molecule by using the incorporation using microalgae, especially for the nutrition for children. So the method used is they determine the amount of apentenesis that's suitable for the white chocolate. And then they will they make 5 white chocolate trials with different amount of aplatenesis, and then they go through color analysis and physicochemical analysis to determine the nutritional value and evaluation for accessory characteristic. This research strand is among the type of chocolate. White chocolate is known for having fewer benefits, but it's still in demand for its taste. So by incorporating microalgae with nutritional value, we increase the nutritional value of the white chocolate and also make it healthy treat for kids. Unanswered question is an increment in the addition of Spectrospira in white chocolates has led to the white chocolates turning to a greenish and bluish color. For future plan, the further study to improve nutritional and sensory attributes of many other snacks and treats by incorporating microalgae into the food. That's all from me. Thank you.
So as for the conclusions, because of their nutritional values and composition, which is similar to that of commonly consumed foods such as beef, beans, and so on, microalgae and macroalgae can be grown as a human foods and animal feeds. Also, they contain pigments that can be used as a natural food colorants. However, it is still underdeveloped, especially in the terms of research and technology to process algae into foods. In addition to that, the cost is still very high. Therefore, further development, scientific research, and also industrial innovations are compulsory, as algae has a very high potential to be used as a future food resource as an alternative to meet the food demands in the upcoming decades.